Awesome. Sweet. Hey, hey. Welcome. Welcome,
Uh,
everybody.
you
All
are so
right.
lucky. 66 degrees over in Cali. I'm sitting in Texas at 101 right now. Just have
Oh, yeah.
Fox fans blasting me down in my room.
Oh, man. I hope you're doing good, man. I hope everyone else is doing good. I'm going to send a link to our general chat really quick. And we'll go ahead and get started. We'll give people a second to come in, join in, send the message to our Discord channel. Glad to see more people trickling in, more people trickling in. Awesome. All right. All right. How's everybody doing? We're doing okay. Last day of camp. Last day of camp. Yeah, we're doing all right. Thumbs up. All right, cool. Can we get a vibe check real quick? 1, not doing good at all. 5, I'm doing great. How are we doing? How are we doing? And if you don't have your cameras on, please turn your cameras on. We're doing good. Making sure that we can get like kind of like that feedback for our speakers as they're going through. It's really huge. One of the best, one of the most amazing feelings I think about this camp is going through presenting and seeing the shock on the faces of the audience as you demonstrate your awesome project. So please help us cultivate that experience. Welcome, everybody. My name is Alex Duffy. I am our head of product here at AI Camp and was part of the kind of collaborative effort that also involved your guys' mentors, ex-students that are part of our internal team tomorrow. We all work together and on this curriculum that you guys just went through in the past 3 weeks, or we have a 1 week team here as well. We're really excited to kind of see these demos, see what you guys did at the end of it. It's something that we put a lot of time and effort in. We really love doing everything we can to make sure that we create the best experience. I'm going to ask for some feedback kind of towards the end. Would love if you guys give us feedback there, because that's a huge part of how we iterate going forward in the future. But yeah, let's get it rolling. So raise your hand if you learned something new this camp. Anybody? We got a few hands. All right. No one, Rocco, I see your hand down. I feel like you guys all have to learn something. So I've got a question for you guys. From when you started this camp to now, what's changed? Is there anybody willing to talk about something that they've learned? Anything. It can be technical, non-technical. Did we learn anything?
Even as an instructor, I feel like I'm learning because I have to learn how to change the curriculum and how to change things around to help out the students to the best of my ability. Even instructors here have to learn.
Definitely. Anyone have anything to add?
I learned how to code.
Yeah, Harold, you learned how to code? You want to elaborate on that a little bit?
I learned how to use good resources.
Learn how to good resources. What did you find yourself going towards?
Just like using like Google and like being able to search up how to do like specific codes and stuff like that.
Definitely. No, for sure. That's something we stress a lot here, is learning how to learn on your own. I got a question about that in a sec. Anyone else? I like coding now. Hey, that's a big development. Come on, let me get a couple real quick. Just like, unmute, say one thing you learned. Let me get a few and then we'll keep going.
I felt like being guided through the courses helped me a lot, because at first I didn't understand. I had to do like a self-learn before in school, and I didn't really understand what it was going through until like my instructors were like walking me through everything and teaching me how it's done.
That's awesome. Awesome. Had someone else off mute?
I learned about different machine learning models, and that was pretty cool.
Different machine learning models. Awesome. So we learned some technical, some non-technical stuff. That's great. I want to highlight a few things here. We also have a 1 week class. So, not everything I say is going to be relevant to what you guys are doing, but at the high level, it is. What I'm stressing here is I want to show you guys just how much you've covered in such a short period of time. During your first week or only week, you guys learned Python, but not just learning Python basics, but how to use it to manipulate real world data. Not in a semester, but in 5 days. And it was light work. A lot of you guys then went on to go into a second week where you learned about machine learning concepts and actually train machine learning models on your own data that you had cultivated the week prior. And in the third week, You made a website to show that off. That's crazy. How much you guys have accomplished in these 3 weeks blows my mind. It should blow yours too. And I hope it drives home the point of what's possible if you put your mind to it and dedicate 4 hours a day and work with a really good team. And hopefully, this AI Camp experience and staying plugged into the Discord will allow you to maybe have more team members, have people to ask questions to. And I am very excited to see updates that you guys give in the future. We learned about using database decision-making. We learned how to use that for not only technical problems, but also life in our career. Another question, or another thing that we focused on, which Tatiana brought up earlier, we focused on self-learning too. Can anyone talk about something that they learned on their own this week, or a problem they were able to fix without the help of an instructor? I know there were a lot. How to manipulate colors in CSS. Thanks, Faye. Yeah, definitely.
I think when coding my model, I was able to gain a lot of resources just from looking online, because there were so many more like tutorials and explanations online that if you just look for it, you can find easily.
Yeah, that was well said. Thank you. That's exactly what we're trying to like point out to you guys, is there's so much open source code out there. There's so much great documentation on things like Medium, Stack Overflow, towards data science, things like that. And all you got to really do to learn it is take it and apply it, or try to solve a specific problem, which is really what we tried to focus on here. Before we get into those projects, last thing I kind of want to ask about is, does anyone have any shout outs for somebody that really helped you out during this 3 weeks, this 1 week, or just someone that you think deserves some recognition for, how much they played a part in your camp experience? Any shout outs? Nobody? We got some. Shout out to Vishnu, #1 lead. We love it. Can I get two?
My entire team, I'd like to shout out.
All right.
Everyone
What's
had
your
their
team
own
name?
Electric Zombies.
Nice. Can we get a round of applause for the Electric Zombies team helping out Joshua? Really helping him have a great experience. Thanks, Joshua. Appreciate you not leaving me hanging. Everyone else, my parents for paying. Definitely a huge shout out to the parents here. Thanks for showing up and supporting. Anyone else? Shout out to Doris. Love seeing the shout outs in the chat. All right, let's keep it going then. Without further ado, we can get into the projects. So for some context, for those of you joining that aren't sure what the project is about, all AI Camp is focused on creating a project and executing it from scratch. The fact that you guys are going through this project end to end is really special. There are a ton of college students and even professional developers who have never built an end-to-end project. And the fact that you guys have already gives you superpowers. The fact that you've understood the dynamics of working with a software development team, that's not easy. Learning about GitHub, learning how, to break apart a large problem into pieces that can be tackled from by each group within a team and then come together to build something really awesome. That's really special. And I'd love to take a sec here. Last question. Can you raise your hand if you think the product or the research that you did could help make people's day better or help people at all? We got some hands up here. That's because you guys focused on really some impactful things that are important to you and also to others. And I think focusing on the problem is something that's really worth iterating here, because if you focus on a problem you really want to solve and time box yourselves, here we did to a 1 week or 3 week, you can build some pretty awesome stuff. So with that, let's see that kind of those projects that you guys built. We'll kick it off with our 1 week team and then keep it rolling with the rest of our 3 week teams. We've got like 6 or 7 presentations today. I'm really excited to see them. With that, I'll turn it over to Cameron and your team if you guys want to kick us off.
Absolutely, absolutely, absolutely. So I had the honor of teaching the 1 week team, as Alex mentioned, and we were talking about various different ways to understand and interpret how mental health affects people in the workplace. So to that end, Disha, if you would be so kind as to share your screen and get us started with our presentation, I would appreciate it. And then Robert, whenever you're ready to start, go on ahead.
Sure. Today I will be presenting with Disha on the company treatment of mental health in the tech workplace. This data study is centered on the question, how does company size affect the treatment of mental health in the tech workplace? And are larger or smaller companies better in treating employees' mental health? We guess that company size greatly affects the treatment of mental health and that employees in larger companies are treated better in terms of their mental health. We analyzed data from that differed throughout company size, such as from 1 employee to more than 1,000, and we created visuals from them. We compared the company size to aspects such as mental health resources, how willing were employees to discuss mental health with their employers, and how much benefits were being provided to them. We collected this data from a survey that was collected in 2014. From these visuals, we concluded that company size does greatly affect the treatment of mental health, and that larger companies are better in treating their employees than smaller companies. We hope to show people another aspect to consider in looking for a job, and how company size can most likely help determine their overall experience in the tech workplace. So this first visual is about company size versus mental health treatment. As you can see, seeking treatment for mental health conditions is fairly consistent across the board. It's not clear or possible to draw any firm conclusions from this data, but this data tells us that there may not be a correlation between the size of the company and the type of employee who would just want to seek out mental health treatment. This second visual answers the question, would talking about mental health with employers have negative consequences? In general, perspectives on discussing mental health difficulties are divided. Some people worry that disclosing their mental health to their workplace will have a detrimental effect. Others don't think it will, and some are not sure at all. Businesses with staff populations of 1 to 100, small companies, think they would not suffer consequences if they talked about mental health, whereas companies with populations of 100 to 1,000, those are the larger companies, think that talking about mental health might have any negative effects. Employees from bigger companies fear talking about mental health because they feel like it could lead to negative consequences. So smaller companies are much more willing to talk about mental health, as it is way less stigmatized and is much more accepted in the workplace. Right. This third visual answers the question, does employers provide resources or help mental health issues? There's a very clear answer to this question. As you can see in the image, there's a very clear pattern above. And as the employee size increases, the number of no answers decreases, the number of don't know increases, and the number of yes increases. This tells us that bigger companies are more accepting about talking about mental health, and they have more resources to help their employees compared to smaller companies. Smaller companies, on the other hand, are more scared of losing employees, especially since their margins are smaller, and they may have a fear that their employees will leave because of mental health issues, which they would want to avoid. Sorry.
Hi, I'm Disha. This a visual shows companies that do have wellness programs. This image makes it quite evident that larger companies are far more likely to have wellness programs than companies with fewer than 1,000 employees. In comparison to smaller companies, larger companies have significantly more funding and resources to offer their employees wellness and mental health initiatives. As a result, they are more likely to implement a wellness program because a higher proportion of people could benefit from it. This visual shows companies that do not have wellness programs. This image directly corresponds to the one before it, supporting our theory. It was obvious that larger businesses with more than 1,000 employees made up the vast bulk of the last image. So now that we have a closer look at this image, we can see that smaller size companies in the survey we used make up the largest proportions of the pie chart that shows that they have a lack of wellness programs. So as I said before, smaller companies don't typically have funding to support wellness programs, which is why they do not implement mental health resources, but instead larger companies do. This graph shows consequences from talking about mental health to coworkers. This bar graph displays how company size affects the response to the question, and the employees either responded with a yes or no. From this graph, there's a clear positive correlation between company size and employees willing to discuss a mental health issue. This does not completely support a theory that larger companies take care of the employees' mental health, but it does show how talking about mental health can pressure employees from discussing them with their coworkers. This visual we created shows discussing mental health with coworkers. Employees in larger companies were reported to have significantly less tendency to discuss mental health with their coworkers than employees in smaller companies. This does not completely coincide with our theory that, that larger companies are taking care of their employees' mental health better, but it gives us a new perspective on how peers are willing to talk to each other based on their company size, as well as their social environment. So our conclusion to the big question, are larger or smaller companies taking care of their employees' mental health better? We can conclude that larger companies are taking care of their employees' mental health problems better than smaller companies. Larger companies provide many resources, have programs that are able to help their employees, and are more willing to talk about mental health. Work gets stressful, so having mental health programs help employees feel supported. As I said, big corporations have benefits and more funding to help their employees seek treatment. And they don't fear as much of losing an employee for some time because it doesn't have as much impact as it would have on a smaller company. Since smaller companies have less financial resources, and as well, the COVID-19 pandemic impacted smaller businesses much more. So overall, larger companies are doing a pretty good job supporting their employees' mental health, and smaller companies are making an effort, but it is understandably much harder for them to implement mental health programs and resources for their employees. Hopefully, in the near future, all companies have mental health programs and resources available for their employees.
Hi, my name is Kalisha, and our mission statement is that we want to see the effects of companies' attitudes towards people with mental health and illnesses. A survey on mental health in the tech workplace was conducted in the year of 2014, and the survey asked a multitude of questions ranging from the participants' family history of mental illnesses to whether or not they feel safe and comfortable with talking to their supervisor about their mental health conditions. From this large data set, our group separated the survey results into 5 separate visuals: wellness programs at work versus how often mental health affects your work, any treatment done versus seeking help, anonymity versus any observed consequences from the mental health conditions, whether or not you're willing to talk to your supervisor about your mental health and seeking help, and if the company provides benefits versus how easily it is to take a leave due to mental health. From the visuals we have created, we were able to explore more and understand in more detail about mental health in the workplace, and concluded that mental health is impacting employees at work, and that if employees provide solutions and programs to help with the mental health conditions, employees will use them to improve their health and experience at work. So our first graph is a wellness program at work versus how often mental health affects your work. So this is a visual showing that even though mental health conditions are interfering with employees at work, there's about the same number of companies with no solutions in a wellness program as there are companies with a wellness program to help alleviate the mental health conditions. This visual is important because the majority of the people in the survey stated that their work will at least somewhat be impacted by mental health. Our next diagram is a pie chart comparing supervisors versus seeking help. This visual shows that more than half of employees working in a company are not provided resources to learn more about mental health issues and how to seek help. However, we can see that the employees that were provided resources, a higher percentage of them sought treatment compared to those that did not seek treatment. This is important because it shows that employees will use the resources provided to them by the company to try to seek help and learn more about mental health issues.
This
Gianna, I think you are frozen.
next graph is on the treatment.
There you go. Sorry, you froze for just a second. You keep going now.
Okay. This next chart is on treatment versus seeking help. This pie chart shows how employees being kept anonymous can affect if they will have observed any mental health consequences. 57% of the respondents said that they did not know if their anonymity was protected, but they did not know any consequence. But they did not have any known consequences for mental health. 25.2% of respondents said they did not know if they were being kept anonymous, and they did not have any consequences for mental health. Our next graph is on anonymity versus observed consequences. The relationship between employees, supervisors, and employers are shown here. Over 50% of employers do not provide resources on seeking help for mental illness, and only 20% of tech employees with mental illnesses are provided with resources. Our next graph is titled, Does the company provide benefits versus how easy it is to take leave for mental health? The bar graph shows how easy it is to take leave depending on whether or not you have benefits. While some employees do not know whether or not they have benefits set up for them if they have mental health issues, it is clear that there is somewhat of a correlation between not being able to take leave for mental health issues and companies not offering benefits for mental health related issues. When companies do provide benefits, it's significantly easier to take leave for mental health than when companies do not provide benefits at all. For many comparisons of survey results from tech employees, we have tried to find the effect of different companies' attitudes towards people with mental health illnesses. We have found that there seems to be a lack of mental health awareness and proper work accommodations such as benefits, leave, anonymity, and other resources. But above that, there seems to be people that feel that they cannot talk to their supervisors or think that they will be receiving negative consequences for admitting to have bad mental health. However, these feelings seem to be tied to not having access to those resources that were previously mentioned. After taking a close look at these statistics, it is evident that tech companies need to take consideration the mental health resources they provide and try to better those resources for the sake of their employees.
Awesome. And then if you guys want to jump into just a brief summary of the week, just going down the list in the order that you guys presented, I would appreciate it.
If possible, for the interest of time, can we would you mind giving everyone, first off, a round of applause for our mental health team here for what you guys put together in 1 week? I think that's awesome. You know, it's definitely tough to dive into a data set, put it all together, create some takeaways, make some visuals, put it all together into a concise presentation. So what you guys did in that week, I think is awesome. So thanks for kicking us off here. We're going to keep it rolling just because I know we have a lot of teams to present. And I think the first team to present from our 3-week teams is our Electric Zombies teams. You guys ready to present next?
Sure, why not?
Yeah, we'll be starting. So can you guys see the screen? Yeah. Yeah, guys, you can start.
Hi, my name's Amelia, and I'm part of the Electric Zombies, a team of 6 that worked on a data science project. Over the past 3 weeks, we built a website that predicts a user's salary based on various inputs like occupation, education, work class, race, and age. So, what is our website really about? Our website is a predictive algorithm that takes in user input and compares it to graphical data that shows the correlation between education, occupation, and salary, and predicts whether someone's salary will be more or less than 50K based off of the given information. When coming up with our project idea, we realized that the majority of high schoolers and even some adults have no idea what they want to pursue as a future career. We've all been at crossroads when it comes to what we want to pursue, and that's why we built our AI model. We hope that our AI can help provide users with a clear path for their future endeavors. Essentially, our goal is to guide users to their future career path based on what they wish to accomplish with their education. So, is our data classification or regression? Classification refers to a binary data set, aka off or on. Regression refers to data that cannot be classified as binary, usually numerical or quantifiable data. Our set is classification because this AI categorizes the data to be either over 50K or under 50K. The data set shows the correlation between education, occupation, age, and salary, and predicts whether someone's salary will be more or less than 50K based on the given information. What is our minimum viable product? Our MVP is a prediction site that provides users with information in regards to their salary. The dataset shows the correlation between education, occupation, and salary, and predicts whether someone's salary will be more or less than 50K based off of the given information. I will now be passing it on to my teammate, Adam.
Hi, I'm Adam. So data cleaning, and I'm going to be talking about data cleaning, is the process of preparing data for future analysis by changing or removing data that's incomplete, incorrect, irrelevant, duplicated, or improperly formatted. This is important because data cleaning ensures quality of the data set and provides better accuracy in its predictions. If data is not cleaned thoroughly, the accuracy of a model may be negatively impacted. For example, let's just talk about healthcare. Clear, more concise records can help speed up a patient's diagnosis. The data can also ensure that effective medication and treatment precision, as everyone needs a medical record. Moving on, the three main ways we cleaned our data was by removing unwanted columns, changing null values, and encoding our data. Before performing any data analysis, we removed unwanted columns since real-world data typically contains too much noise and only a few columns provide useful information. Another issue with real-world data is that it tends to comes with gaps in the data, which are called null values. We treat this issue by imputing the null values with the mean, median, and mode or nearby values. Now we solve the two main issues. Our numerical and categorical data are required to be encoded, as machine learning only understands numeric data. These categorical values are encoded to zeros and ones, making them recognizable to machines and for our progs to work. I'll now be passing it off to my teammate, Aaron.
Exploratory data analysis. So why is it important? Because it finds all the data before coming to any assumption. So there's no personal bias. It's just numbers. It's just how it just shows how it is, and that's what's great about it. So let's take a look at the first graph, gender distribution. It shows the correlation between each gender, the male and female. And as you guys can notice from the graph, male overwhelmingly has a higher percentage than a female to their female counterpart. Now there are very complex variables. It's not simply just because it's just how it is. There's certain things in life that just have certain variables, like certain workforces, like architecture, carpentry. Those kind of workforces require a lot more people involved than, let's say, a teacher or a therapist, which communication jobs are more common among women. So what this and then as you can see from the graph, and what's interesting about this graph, and I wouldn't be able to tell you why, is that from under 50K, female has a 38%, but it drops significantly once female goes over 50K. I don't know how, that's just how it is. Let's take a look at the second graph. Gender pay gap. So this basically shows whether or not higher number of education years determine higher salary, which in short it does. But what's interesting is on average, women have to do a lot more education years in order to make the same amount of money as men. You can see here 12 to 11 years for women, and then 10 to 9 for men in order to make a good amount of money. This may be because certain occupations that common women that have education, or which is common, is like doctors, nurses, and teachers. Those kind of things require a lot of years in order to even to get the right skills and such. Let's take a look at this next graph, race. So as you guys can tell, if it loads, there we go. As you guys can tell, there's one glaring one. It's the one in the middle, and that's the Asian Pacific Islanders. They, on average, have to have more educational years in order to make the same amount of money as the race counterparts. And this is this is not really all accurate because of such a large sample size. Because even though they might have a couple figures that are making a lot of money, they also have a lot of people that don't make a good enough money. So as a result of that, it fluctuates and makes the whole graph skewed. Next point, age distribution. This is probably the most, if it loads, but it's the most important aspect to any workforce. It's experience. And typically, the older you are, the more experience you have in that certain mastery, certain skill for that. I'm sorry, excuse me. But it's a huge part of the work field. And this doesn't really take to consider like outliers like athletes who make a lot of money despite being very young. This is just the overall average of how it is, and just the trend of how it works. And let's move on to the next point, higher education. And you guys can see here from the graph yourself that nothing is guaranteed in this world, but it increases the likelihood of, depending on what education you get. You can take a look at bachelor's. Bachelor's has a 28.3 to make over 50K, while only 12.7 make under 50K. So nothing is guaranteed. You can take 15 years of education, doesn't matter. It just increases the likelihood of succeeding into a better opportunity. You can take a look here, master's 3.52% at under 50K, while over 50K is about 12.2. And you could be successful as a high school graduate, but the probability of that happening is very unlikely. And then finally, to the heat map. And simply what this shows is it shows the importance of each variable into for it to succeeding, like a salary over 50K. It shows age, education numbers, hours per week, but the most important of them all is education number, as it has the highest number. It has a 34% chance or for it to matter. And I would like to pass to my teammate Shalene.
Okay, so for my part, basically for solving any machine learning problems, we need to follow certain steps, from acquiring the data all the way to actually building the deep learning models. As a whole, this process is called the machine learning pipeline. So for the first part of this, it's basically feature engineering. It's a process of selecting, manipulating, and transforming the raw data into features to be used for supervised learning. With data validation in the works, the accuracy and quality of our source data improves significantly. Next is to test, train, and split. This step's ultimate function is to estimate the performance of the machine learning algorithms to be applied to prediction-based applications. We split the data into two parts, training data and test data. As the names imply, training data is to train the learning model, and the test data is to evaluate and test the performance of this model. Next is the encoding. Since real-world data contains both numerical and categorical data, the categorical columns are required to be encoded in order for the computer to be able to understand it, as it is not able to process non-numeric data. These inserted values are encoded to zeros and ones. Then, finally, it is time to build our models. We build 3 for our data: logistic regression, random forest, and neural network. These models are used to classify our data. We then compare the 3 models to find the neural network provided the highest accuracy result with an 84% accuracy. This model is ultimately the one that handles the predictions. Next, I'll be passing along explaining models to my teammate Joshua.
Hi. Sorry about that. Hi. We have, out of all the models that we could have used, we used 3 that we used to graph our data. The first of being logistic regression, which is a method used to predict a binary outcome such as yes or no, based on prior observations of a data set. A logistic regression model predicts a dependent data variable by analyzing the relationship between one or more existing variables. In logistic regression, an S-shaped logistic function is used to predict 2 maximum values, either 0 or 1. The curve from the logistic regression function indicates the likelihood of the occurrence of each data piece. This chart down here is our confusion matrix for logistic regressions, which shows the actual values and the predicted values of that logistic regression had. We had an accuracy of 82%, a precision of 0.87, a recall of 0.90, and an F1 score of 0.88. Our next model, random forests, uses a sequence of decision trees that perform classification or regression by asking true or false questions. These then get solved with a majority vote. Each tree makes a class prediction, and the prediction with the most votes becomes our model's final prediction. By using uncorrelated trees who give individual outputs, the random forest model generates a prediction by the committee that is more accurate than any individual tree. This is the confusion matrix for random forest. It's pretty much the same thing as logistic regression, except it has different values. We had an accuracy of 82%, a precision of 0.87, a recall of 0.90, and an F1 score of 88. I'll now be passing on to my teammate, Karen.
Thank you. Okay, so I'm going to be talking about the last model that we use, which was neural networks. So neural network is a method in artificial intelligence that teaches computers to process data in a way that is inspired by the human brain. It is a type of machine learning process called deep learning that uses interconnected nodes and neurons in a layered structure that resembles the human brain. Some projects that use neural network today on a daily basis include weather forecasting, credit scoring websites, and fraud detection systems. So for our accuracy score, this one actually scored the highest compared to logistic regression and random forest with an accuracy score of 84%. It had a precision of 0.87, a recall of 0.92, and an F1 score of 0.90. So down here we have our classification matrix, and basically these are what we use to evaluate the three models that we had, which were logistic regression, random forest, and neural networks. And finally, for our salary predictor, basically an individual can input a number of personal attributes such as age, education, work class into the system. The input is later sent to the model, which in our case was neural network since it had the highest accuracy score. And once the input is set, it provides an output to users on whether their personal attributes would allow them to have an income greater than 50K or less than 50K. I will now be passing it on to my teammate Amelia to conclude. To conclude, after analyzing our data, we found that out of all of the classification models, neural networks work the best for predicting salary. Our logistic regression and random forest models both had an accuracy of around 82%, while our neural network model had an accuracy of around 84%, making it the best of the three that we used. From the analysis, we can conclude that there is in fact a relation between level of education, age, race, and income received by a person. However, there are still ways for us to advance our predictions. We can better improve this machine learning model if we have more diverse data and also more data points. We hope that our model can help people make more informed decisions about their future. Thank you for listening.
And special thanks to, I'll just thank my team. Special thanks to Aaron, Adam, Emilia, and Joshua, Karen, and Shalene. So without you, I think this is not possible. You worked very hard for all 3 weeks. It might be exhausting for you sitting 3 weeks and learning a new stuff, but you did very good. I'm really proud of you. You made end product very beautifully. Okay.
Yeah, can we follow that up with a round of applause? I mean, that was an awesome presentation, professional presentation. Transitions were great. Website looks beautiful. I think it's an awesome project. You guys did a great job. Seriously. All right, let's keep it going. Who do we got next? We've got the random searchers. You guys are up next, right?
Yes, my group is next.
We might have to stop sharing screen. Oh.
All right, I'll start sharing my screen. All right, well, thank you all for being here. Our group is the Random Searchers, and we have prepared a data science project without strokes.
So to start off, a stroke is a medical emergency where blood flow to the brain is dangerously restricted, resulting in brain cell death. According to a 2018 study in the New England Journal of Medicine, 1 in 4 people over the age of 25 will have a stroke in their lifetime. If it's not treated properly, after effects can include restricted motion, paralysis, and difficulty communicating. The purpose of this project is to raise awareness of strokes and potential risk factors for strokes. This project uses a dataset from Kaggle, which contains features that can be used to predict strokes. Some features that we analyze include BMI, average glucose level, gender, whether someone's ever been married, and age. So why did we clean the data? The most important factor in data science is data. No matter what sophisticated machine learning models are used, the models are only as good as the data. Given a data set, there are usually false data points and missing data that could compromise the accuracy of our modeling, and cleaning data helps identify and remove errors. So the way we handled missing values, well, only BMI was missing any data. So we imputed this column by filling the missing values in with the mean of BMI. And for handling outliers, all of the numerical data in our data set had some outliers, but we left them in because they were values that were improbable, but not impossible. Handling imbalanced data. Imbalanced data occurs when one of the target classes makes up a small proportion of the data, and our data is imbalanced because someone is much less likely to have a stroke than to not have a stroke. So we use SMOTE to balance our data. SMOTE balances data by synthesizing data with minority targets.
And now we have exploratory data analysis. As you can see above that our data was definitely imbalanced because it's unlikely for someone to have a stroke compared to not having one. And the target column is stroke with 0 representing no strokes and 1 representing strokes because we needed to put it in order for the computer to understand. As shown by the chart, the data is imbalanced with about 5% of the data consisting of samples with a stroke. Now is our pie chart. This one is on if someone was ever married and how that is in relation to strokes. It compares the proportion of strokes in people who have been married and people who have never been married. There's a slightly greater proportion of individuals with strokes for people that have been married. Our next pie chart is on stroke and gender. This pie chart compares the proportion of strokes based on being male or female. Most studies have found that females are more likely to have a stroke. However, this dataset sampled a population of people with a slightly greater proportion of males that had a stroke. It's a very slight difference, but it's interesting because either the people in our data sample tended to just have strokes either way and didn't reflect the majority population, or there could be, and generally it's just interesting things to think about in relation to previous research that has been done. And our next chart is on the proportion of stroke versus age. This chart demonstrates the relation between stroke and age. An increasing line shows a positive correlation between age and stroke likelihood. As you can see, there are a few outliers, such as at the age 0, babies can have strokes, for example. That was an example of an outlier that was definitely possible, but you can definitely see as well that your likelihood of having a stroke increases as you age. Average glucose level and age in relation to stroke is our next chart. This chart shows the relationship of those things. The blue dots represent an individual who has had a stroke. The region with the highest proportion of strokes occur at higher average glucose levels in old age. As you can see, the biggest concentration tends to be above 150 for their average glucose level, and age 60 and above, or perhaps age 50 and above for the highest level of people who have had strokes. The yellow dots are just people who have not had strokes, but the highest concentration of blue dots is in that region. Our final chart is our stroke data correlation heat map. As you can see, is a correlation heat map of subset of features used in our data set. The subset of features shown include only features that have an absolute correlation of at least 0.08 with the stroke column. This figure is useful in feature selection for machine learning and useful for observing direct correlations between input features in the stroke column. This would be useful for feature selection if something was very, very closely coordinated and we could just get rid of it because that would be redundant. And the one you see there is just like, you don't need to pay attention to that. But the one stuff that's most important in our research is the stroke column or stroke row, but for this example, let's just look at the stroke column. As you can see, there's a very high correlation between stroke and age, which would be interesting. However, that is not the only fascinating thing that we need to pay attention on to this, because there's other helpful information such as possible correlation between age and hypertension. Stroke is simply just the stuff that we have our research focused on, as that is the target. And now to pass it on to the rest of the team.
Machine learning is a field of study that uses mathematical algorithms and data to make predictions and enhance the performance of tasks. Machine learning is considered to be a component of artificial intelligence. Machine learning models learn by using data to tune hyperparameters in the machine learning model. Machine learning is utilized in a wide range of applications, including speech recognition, email filtering, computer vision, and medicine. For our data set, the target column strokes only has 2 classes, having a stroke and not having a stroke. Therefore, we explored machine learning algorithms for binary classification.
Logistic regression was the first binary classifier we used in our project. Logistic regression produces a probability which is compared to a threshold. If the probability is above the threshold, it is considered a positive case. The figure below is a confusion matrix which represents the predictions of our model. The value on the top left represents correct negative predictions our model made, and the volume on the bottom right represents correct positive predictions our model made. The other values represent incorrect predictions, and the top right is false positive and the bottom left is false negative. For our dataset, logistic regression had a low accuracy of 54%. However, the recall rate was high of a 98%. Recall is the number of true positives divided by the sum of true positives and false negatives.
The decision tree classifier was created around the 1960s. However, a similar concept has been used since the earliest written records. A decision tree classifier is a supervised machine learning algorithm that uses a tree-like structure to categorize outcomes based on the answers to a previous set of questions. In terms of accuracy, the decision tree classifier performed better than the logistic regression with an accuracy of 80%. However, the recall rate was low. Above is an example of a decision tree classifier, and below is the decision tree confusion matrix.
Multi-layer perceptrons, or neural networks, are another machine learning algorithm that use connections, active functions, and layers to predict an output. Multi-layer perceptrons can function as a nonlinear function approximator for either classification or regression. The study of neural networks is a subset of machine learning called deep learning. Deep learning can make predictions on advanced tasks like self-driving cars and conversational virtual robots like Siri. Regarding predictions on our stroke dataset, the multi-layer perceptron model had the highest accuracy of 88%, but the lowest recall of 28%.
Machine learning results. The applicability of our models depend on the use case for stroke diagnosis. If one wants to use a model with very high accuracy, a null predictor, predicting everyone to not have a stroke, will be correct 96% of the time. However, if one wants to capture the population at high risk for a stroke, the logistic regression model performed best with a 0.98 recall in the has had a stroke category. On to our conclusion. From exploratory data analysis, we observed that the most impactful stroke factors were age, average glucose lunch test. The percentage of individuals that have had a stroke increases after the age of 40. Additionally, individuals with higher average glucose levels and married individuals both have an increased risk of having a stroke. Regarding model predictions, it was difficult to improve accuracy past the null accuracy for this dataset. It was relatively small, just about 5,000 samples, with a highly imbalanced target distribution, which was about 5% minority class. Since models perform only as well as the quality of the data, the main improvement for future experiments in stroke prevention would be to increase the quantity and the diversity of the data.
Well, these are the members of our amazing team. Each member worked hard over the past few weeks to learn Python, data science, and web development. Thank you all for listening.
Awesome. Can we get a round of applause for our Random Searchers team? Awesome presentation. Sorry, my connection's cutting in and out here, so hopefully you guys can still hear me. I thought that was a great presentation. You guys went through it like pros. See some awesome comments on the topic itself, but let's keep it rolling. All right, so who do we got next? We got parallel processing. I think you guys are presenting next.
Yes, I will share my screen.
Awesome.
Okay. Hello, everybody. We are the parallel processors, and we are very excited to be sharing our final project with you. Now, what does our project do? What is our goal? Why does it matter? Well, our goal for this project is to be able to create a model that can classify whether or not a person has diabetes by using a data set that includes several health levels, such as glucose, insulin, age, BMI. Our team is able to train our model to identify the symptom levels of diabetes. However, which levels are the most correlated factors to whether or not an individual has diabetes? The person that will be answering that is my amazing teammate, Landon.
So for our exploration of data section, a heat map's main purpose is to display the correlation between features in a data set. If you look below, you can see all the features, glucose, BMI, etc., and the correlation to the outcome. Use the info on the highest correlation, which is glucose to the outcome, but we didn't use all of the information for the main project. Harold's section now.
All right. After the heat map, we made a box plot to find the outliers in our data set. The rectangles show the average for each variable. The singular dots are the ones we would consider abnormal or the outliers. We use this type of visual to see the outliers in our data set, and this was important because these outliers can decrease the accuracy of our data set. So once we removed them, naturally the accuracy went up. After this, we had scatter plots. So after we made scatter plots to see the correlation between two variables, one of which was the outcome. Scatter plots are useful because we can see certain variables have a higher correlation than others. These people are the ones who have diabetes. We also use scatter plots because the features were numerical, which is visualized better in scatter plots. Now I'll pass it off to Rocco.
Logistic regression is used when predicting an outcome based on a fixed variable, such as determining possible risk of disease using health factors like glucose level and BMI, body mass index. Before predicting an outcome, filtering through data is usually the best course of action because it allows faulty data to be discarded, such as if the data set displays someone's blood pressure as 0 or 400. The logistic regression accuracy that we got was 84.6%. The confusion matrix shows that there are about 11 false negatives, which is a very bad number when dealing with medical diagnostics.
K nearest neighbors takes a data point and finds like a K number of points next to that data point. So for example, if K was equal to 5, K nearest neighbors would find the 5 nearest neighbors and chooses the class of neighbor that has the majority. Because K nearest neighbors chooses a majority, K cannot be an even number because there's a possibility for a tie. In this data set, I tested many different K values and we found that K is equal to 47, gave the highest accuracy with 85.9%. Looking at the confusion matrix, there are 10 false negatives. In the future, I'd like to reduce that number.
So random forests work by making like decision trees and then passing a data point through each one of these trees for an outcome. And then basically it just averages all of the outcomes from all of the trees to make a final result or classification and final class. So to increase our accuracy of the thing, we took out some outliers and applied like the most relevant points with like a range of insulin, for example. And we got the accuracy to be around 80.7%. And from the matrix, you can see like it's pretty accurate, but there are 9 false positives or negatives, which is not that great.
Okay, so now for our conclusion. Based on the results, our team has come to the conclusion that K nearest neighbors has performed the best compared to all machine learning models. With cleaning the data and handling the outliers, all models were able to get to significantly high accuracy points, such as logistic regression got to 84.6, K nearest neighbors got to 85.9, random forest got to 80.7. However, it is important to keep in mind that although K nearest neighbors resulted in the highest accuracy, it was random forest that had the best recall, meaning it had the highest chance of accurately diagnosing the symptom levels for diabetes. Now, since our data set is not the most significant and recent research, including a good amount of false negative values, further research must be done in order to use this model in the real world. However, with more recent research and data, this model could be able to prevent people from experiencing harsh effects of untreated diabetes, along with helping people try and reverse it. If our model is able to point out diabetes early enough, then the individual has a chance of reversing their condition. Thank you for listening, and that is our presentation.
Yes, and then I also just want to shout out everyone on my team. They were all first-time coders, so being able to do all this is just really incredible. So I want to shout out to Harold, Yifan, Rocco, Hari, Tatiana, and Landon. And then last but not least, we put in our bang-in parallel processing playlist that we played throughout this camp. It's just something that we bonded over, and we wanted to include it on our final website.
Awesome, awesome, awesome. So as Alex mentioned, his computer is absolutely just going haywire. I think he just mentioned his Zoom crashed and is currently freaking out at me in Discord, but that is a-okay. I'll be happy to take over for a bit. So if we could get a round of applause for our wonderful team. Awesome, awesome, awesome. So I think up next we have the Elastic Searchers.
Yeah.
So whenever you guys are ready, feel free to get started.
I'll be sharing my screen. Thank you, Cameron. Betsy, whenever you're ready.
Hi guys, I'm Betsy, and today I will be presenting or introducing our final product and our website. So our website was all around the topic of diabetes, and what we really wanted to focus on was some sort of way people can self-evaluate themselves to see whether they're prone to have diabetes or not. So the why, according to the CDC, diabetes is a chronic disorder that impacts how a person's body converts food into energy. Diabetes slows down or stops the production of insulin, increasing the amount of glucose or blood sugar. This increase leads to heart disease, vision loss, and other serious health problems. Our objective is to spread awareness on the topic of diabetes. It is something that a person can carry through their life without knowing. The purpose of our website is to aid people in self-evaluating to see whether they may or may not be prone to having diabetes. Exploration of our data. Our data is derived with a 2019 diabetes dataset from Kaggle. The evaluated factors include age, gender, family diabetes, high blood pressure, prediabetes, physical activity, BMI, smoking, alcohol, sleep, sound sleep, regular medicine, junk food, stress, BP levels, pregnancies, and urination. And the significance or extensions of this project could be that it's easy to help detect diabetes and easy to access. And the best part is that it's free and you don't have to pay for it. I will now be passing on to Isaac.
All right. When we were introduced to AI Camp, we were told to create a project based on our interests. So we created a website to help people self-diagnose themselves to see if they had diabetes. For our first week, we just covered the basics of Python and graphing our data. For the second week, we took that data and plugged it in and trained it using machine learning models. And for the final week, we built a website using all the stuff we had learned previously to help people self-diagnose for diabetes.
Now that you have a good understanding of the data set itself and the struggle that came when getting to week 3, and today, the final day of AI Camp, we can finally get into the visualizations. In our first visualization, we compared age and gender, and it was taken into account when determining the overall likelihood of an individual contracting diabetes. This makes sense, as a basic genotypic trait should always be considered in any disease. When looking at this graph, you will notice that both graphs for males and females are exactly the same when discussing their status of diabetes. Though this turnout may not seem like much value, it shows a good scale of what groups of age specifically are more vulnerable than the others. Those in the age range of 40 and lower have fewer tendencies of gaining diabetes, while those older than such range start to contract the virus. While this will play an important role when considering the following graphs. Now that the basis has been set for the individuals, we can start exploring certain factors and how they pertain to each age group. In the next graph, we look at physical activity of the age groups. All the graphs that provide some form of physical activity have those that are 40 and lower being the core leader. This means that there is some sort of correlation between staying physically active and diabetes outcomes. With such a vast difference between physical activities throughout the ages, this factor must be heavily considered when talking about the vulnerability to diabetes. Now that physical activity is out of the way, we can correlate such information into the overall body mass index when comparing the two genders generally. Since we already know that there is no difference when it comes to age and gender, but there is a difference in age and physical activity, it's a good thing to investigate what differences there can be in a phenotypic sense with BMI. According to the National Health Service, being below the BMI of 18.5, you're considered underweight. And if you're within the range of 18.5 and 24.5, you're considered to be at a healthy weight. And if you are in the range of 25 to 29.9, you're considered overweight. When taking a glance at the graphs and the differing genders, blue being male and red being female, you notice pretty significant differences. To compare, the majority of those who underwent this factor test are in the healthy BMI range. However, you'll notice the amount of underweight and overweight BMI testers when comparing the two genders show that those specific factors are found mainly in women. Though we need to double back and realize that ultimately BMI doesn't play a huge or noticeable factor in diabetes as supported in the first graph. Moving along, we can now take a look at quality sleep in relation to stress and its correlation to diabetes. These two graphs don't show much significant difference in the way they are formed, but that doesn't mean sound sleep and stress aren't factors in diabetes. As the red graphs clearly show that there is not much difference in the way the graphs are formed, there's still an overall more prevalence of diabetes forming in those that do not get sound sleep, even without the regard for stress. This is most likely due to the insulin resistance decrease that occurs when someone lacks sleep. But since that isn't inside the graph itself, I won't go into much further detail. Another factor that we investigated to determine if the stress was correlated to diabetes was the effect of smoking on stress. According to those that were tested, the majority of those that frequently smoke report that they aren't under constant stress. We know from science done and from credible sources and the plethora of advertisement to quit smoking that there is some sort of stress buildup over time. However, this graph is specifically meant to show smoking always having stress, which there seems to be very few according to the testers. And when looking at the correlation of these two factors to diabetes itself, there is a minor correlation between the two, but outside factors must be considered as the way someone contracts diabetes is not one size fits all. From one unhealthy habit to another, we also decided to investigate the association between age and junk food when linking them to diabetes. The blue marker shows those who are in the age range of 40 and lower. You can see that in every aspect, the age group consumes the most amount of junk food, but they are also the widest range in terms of ages, so the math checks out. What's eye-opening is that even though they take in the most amount of junk food, they still don't contract diabetes with these unhealthy habits. While the other groups are represented in a scattered fashion throughout, the red markers, they do have diabetes when looking at their junk food intake. This probably goes hand in hand with the physical activity the age groups undertake, which is also in favor of the groups 40 and younger. Even with this information, it's safe to assume that there is some form of correlation between junk food and diabetes. Lastly, we looked at the age groups and their alcohol intake. While this graph doesn't show statistics when considering diabetes, most of the participants didn't drink alcohol, but for those that did, we see that the age range of 59 and younger drink the most amount of alcohol.
So now we're going to start talking about our models. Here you're going to see just the matrix models and then explanation of what the models are and which ones we used. As you can see, we use classification models such as logistic regression, SVM with and without standard scalar, and random forest, since we are predicting a discrete class label. First off, as you can see, we have logistic regression, which calculates the probability of or likeliness of an event happening using a given data set of independent variables, with the dependent variables valuing between 0 and 1. Then we have random forest, which uses decision trees and averages out the outputs to find the final prediction. We also have a support vector machine with and without standard scalar, which are supervised learning models with associated learning algorithms that analyze data for classification and regression problems. using hyperplanes or lines that separate the data into two categories, either having or not having, or yes or no, which is perfect since we're trying to identify whether someone had diabetes or not. As you can see in our matrix models, our true positives for logistic regression, SVM, with standard scalar and random forest are all average around 5-ish, while SVM without standard scalar was the highest, having 60. Now onto our results and conclusions, where we compare all of our models on their F1 scores and accuracy. By taking harmonic mean from each model's precision and recall, we can compare each of their performances, which is basically what F1 looks at and does. As you can see when looking at our graphs, the x-axis will be the models, and the y-axis will be either F1 or accuracy, with SVM being closer to 0.9 compared to the rest, which are closer to 0.8 in the F1 graph, which is the first graph, and the with SVM closer to 1 compared to the rest, which are closer to 0.9 in terms of accuracy, with SVM performing the highest overall. Now let's look at our product.
Yeah, so now to self-evaluation. As you can see here, almost all the categories from the original data set are here, except for diabetic, because that's what we're testing for. So for categories such as age, you have options to choose from that mimic the original data set. And for categories such as BMI, you have to put in a numerical value. So once you put in all the values, the SVM machine compares it to the original data set and makes a prediction based off of it. So now you just press evaluate, and then
I think our server is not running right now. But ideally it should pops up a text set that diagnosed as diabetic.
Yeah.
1 sec.
Okay.
Okay. And then you can follow in with the team.
Oh wait, I just want to add something to the self-evaluation.
Oh, okay.
So, there might be some complications with the prediction, as the person may not put in the right or correct values about health information, and the machine isn't 100% accurate, although highly accurate. So there might be some complications with that. However, it can make the person make better health-related decisions and be more aware of diabetes. Okay, and then after you press evaluate, you just scroll down, and then you should have your diagnosis. Yep, okay. Then onto our team. So we all had very little knowledge on coding, but we wanted to apply it to real-world applications. So after 3 weeks, we got our data set and learned about machine learning, the basics of Python, etc., which helped us create this website and aid others in self-diagnosis of diabetes. So there's zero payment needed, as mentioned before, and we hope that you got something out of this presentation. Thank you so much for listening.
Awesome. I'm the instructor. Thank you all. You all did great. I'm great to have you all.
Awesome. Awesome. Thank you guys so much for that presentation. If you get a round of applause for them, I would appreciate it. Super interesting stuff. And I really like just your ability to enter your own information so you can make those healthful or mindful decisions about your health. So keeping us rolling, I believe the placebo detectors are up next. So
yeah, we are next. I will share my screen. Okay, can you guys see my screen?
Yep.
Okay, cool. Hi everyone, we are the team placebo detectors, and our project is called Heart Attack Data Analysis. So for today's presentation, we will have overview, EDA, machine learning models, conclusion, our team, those 5 parts. And I will let my students go through all of them and introduce the whole project to you. So Himani, you can be the first.
So we collected our data set from Kaggle, and it predicts whether or not certain individuals had a heart attack through focusing on varying health conditions that these subjects have. This data set contains 14 different variables such as age, sex, resting blood sugar, and maximum heart rate achieved. And if you click on our data set, you're going to see that there's 14 columns and more than 300 rows right here.
Yeah, this is Kaggle's page of our data set.
And we also created multiple visual models to help predict the chance of having a heart attack. I'm going to pass it to Hamza to talk about the EDA.
So this is so we're gonna go over our exploratory data analysis, and over here is just an example of our data set. And as you can see, there are 14 different columns, including output. And basically the columns represent different, I guess, biometric data about the person. For example, you can see there's an age column, a sex column, a chest pain type column, the person's resting blood pressure, the person's cholesterol measurement in micrograms per deciliter, and so on. And basically what happens is the output column just shows the chance of the person having a heart attack. 1 means that there's a greater chance of having a heart attack, and 0 it means that there's a less chance of having a heart attack. And here's our correlation heat map. So first we created a correlation table to show how different medical metrics correlated with the heart attack risk of a person, and just how they relate with each other. And as you can see over here, there isn't much correlation in between the variables, as most of them have a correlation of under 0.1. And I'm gonna pass it over to Caroline so she can explain the different data visualizations we use.
We made graphs for the variables age and sex to see how much they affected the chance for someone to have a heart attack and see which type of people had the highest risk. This is the graph for risk based on sex. It shows that the chances are similar for both males and females, but males have the highest probability overall. This is the graph for risk based on age. As you can see from this histogram, there's a peak when the age is 41 to 45, and the age is 51 to 54. The graph also shows that people below the age of 40 and above the age of 70 have a lower chance. Because of this, the ones who have the highest risk are people from the ages 40 to 60. And they should be more careful to regularly check for the warning signs of a heart attack. I'll pass it to Anya.
We integrated several machine learning models in our project, as machine learning is an important aspect of our project that allows users to submit their data into our program and analyzes it to make decisions based on input data. By examining variables such as age and sex, our models can predict the chances of a possible heart attack. We also used a confusion matrix after all of our models to show us how well our model is performing, what kinds of errors are being made, and an overall overview of what we need to change to make our model as efficient as possible. So we used 4 kinds of classification models. I will be talking about the first 2, which are the KNN models and the SVM models. The KNN model is a supervised learning model that uses distance between neighbors around a point to check how similar they are and classify the point. The K is the amount of surrounding points that will be considered to classify a point. In our KNN model, we created a for loop to find the optimal K value that gives us the best accuracy for classifying whether someone will experience a heart attack or not. When we plugged in one of our optimal K values, we got an accuracy of 88.5% and a recall value of 0.89. As you can see in our graph, in our confusion matrix, the number of true positives and true negatives are a lot higher than the number of false positives and false negatives. Moving on to our second model, the SVM model. The SVM model is a model that finds a hyperplane or divider in n-dimensional space that helps separate and distinctly classify points to separate the 2 classes of data. We needed help from the computer to choose a hyperplane that provides the best accuracy when classifying data points. So SVM models were a perfect fit for our classification application. As you can see in our confusion matrix, our true positives and true negatives are also a lot higher than our false positives and false negatives. In addition to this code, we also used a grid search to help tune our hyperparameters so we could find the best possible accuracy. And we ended up with an accuracy of 85.2%. I will be passing the next 2 models on to Kalani.
Okay, so we made a random forest model to measure how accurate it was when classifying whether a person will have a heart attack or not. And in the images, the visual graph displays a for loop code that helps tune the hyperparameters of n estimators and random state variables. And we also created 2 models of cross-validation, and they're called K-fold cross-validation and grid search cross-validation. The K-fold CV creates and tests training and testing models, while grid search finds the best parameters to use. And for each cross-validation model, we made confusion matrices to make sure our accuracies were consistent. And our last figure is the gradient boosting model. It predicts the best output value, which would be classifying a heart attack or not, and it minimizes errors made from past models. We provided images of an ROV curve and a precision recall curve, which both show the correlation between true and false positive rates. And similar to random forest, we also made a grid search model and confusion matrix to tune hyperparameters and help maintain a high consistent accuracy. And now I will pass it on to my teammate, Cecilia.
So in conclusion, we created this table that compares all the accuracy, recall, and precision values. And upon reviewing this, we decided that our random forest models would be the best as it yields the best accuracy for the predicting the likelihood of having a heart attack, comparing it to the rest of our models in general. This is mostly the reason why this model does so great is for the fact that it uses various decision trees that then collect samples of the data set, and each decision tree then averages them out to make a final prediction, resulting in its high accuracy. So the reason why our end result and this data set in general is so significant is because this project as a whole has made it possible for a person who would have never known that they had a heart attack be able to find out if they are in a higher risk than they thought. This will allow them to take more preventative measures, such as like going to the doctor or lowering their blood pressure or going on a diet, just to have a better, healthier lifestyle and avoid this. And it is plausible that in the long run, if our project was to be implemented, that this project could help even eliminate the possibility of someone having a heart attack long term.
Hey, thanks, Cecilia. So at the end of our presentation, please let me introduce my team and my students. We have Hamza, Imani, Cecilia, Kelani, Caroline, Enya, and me as an instructor. So my students all did a good job, thanks to them. And thanks all for listening. That's all.
Awesome, awesome, awesome. We get a round of applause for our placebo detectors. Thank you guys so very much for presenting and putting together that awesome website for us. And I believe last but absolutely not least, it should be the Valorious vampires. Did I say that? Ooh, please don't make fun of me.
Okay, let me share the screen.
Hello, and on behalf of the Valerius Vampires, I welcome you to AVA, the Interactive Avocado Value Optimizer. So our group chose the dataset Avocado Prices, containing information regarding the sale of Hass avocados throughout the nation from January 2015 to November 2020 throughout the United States. For each recorded date of the sales to distributors across the nation, the average price, total volume sold, total number of bags of each type sold, and the region were provided. At first, we chose this data set because it would allow us to have a lot of flexibility to make visualizations and machine learning models. But as we went on, it became clear that this would help solve an issue that is much more dire. This issue is called food waste. In fact, recent statistics have gone on to show that 80 out of the 81,000 tons of avocados produced in just one location, Kenya, around 30,000 to 40,000 have gone to waste. Our product will generalize the price of avocados, ensuring that the most efficient price is placed upon this commodity, hereby reducing the amount of avocados that rot away in stores and warehouses, unused and unbought. And this is our data set that you can see. We got a data set that has over 18,000 rows to provide us with sufficient information to create evaluations.
The goal of our project, AVO, is to learn from past data and trends to accurately predict avocado prices. AVO will help sellers, manufacturers, and consumers all around. Sellers in particular will be able to identify the optimal price for avocados and maximize their exports, and consumers will benefit from locating the cheapest areas to purchase avocados. Some brief observations of our data include that the price of an avocado usually fell between 44 cents and $3.25, with an overall average price around $1.40. There was also a mean of 850,000 avocados sold in each region. And lastly, the region that sold the most avocados was the West, selling an average of 3.2 million avocados each day.
We analyzed the following heat map and tried to choose factors that had high correlation with each other. However, the average price had a weak correlation with almost all of the factors. And for this reason, we decided to choose it to make evaluations based on it, because the average price is possibly the most important factor out of all of the factors.
So to demonstrate the average price and model it over time, we used a line graph. With this line graph, we were able to visualize the pricing of avocados throughout the years. This helped see the fluctuation of pricing as well as the general increase in trends and variance over time. It can be seen that the prices often vary, but there is a general increase in prices over time.
And also, using a bar chart with long formatted data, we track the amount of bags of avocados that each region in the US acquired per year, and we were able to identify a significant increase in demand for avocados over those time periods.
In addition, using a bubble plot in a group data set, we were able to identify the price ranges in which companies sold the most number of bags of produce. As you can see, when avocados are priced around 70 cents to $1, the companies sold the greatest amount of produce. This information can then be used by corporations to make evaluations based on the on the price that they should place upon avocados. Next up is our machine learning models. Each of the members of our group created our own models and used our own creativity to generate the model that we thought would be best fit for each of the data sets.
All right, so for my model, I created an LSTM neural network, and I wanted to be able to predict the prices of the avocado in a given state. I picked a specific state instead of the nation because prices often change from state to state, but this can be changed just by altering the data set. In this specific model, I looked for California. So I used the LSTM model to predict the prices in California for the next month. I first modified the data set so it only reflects the avocado prices in California. Using that data from the previous 30 days, I used a look back of 30 for my neural network to then predict the prices for the next 30 days. I had a training set of 60% and a testing of 40. So that the testing could be better visualized on the graph itself. And the training set is represented in orange and the testing is represented in green. If you can see, the blue is the actual price, and I used that to compare how accurate my prediction was and was able to correctly predict the fluctuation of prices.
I created an XGBoost regression model for our avocado dataset, and each branch of my tree represents a region or location and possesses a leaf containing the prediction for the prices of avocados for that specific region, whether the price will be greater than $1 or less than $1. Essentially, it takes the average prices of all avocados in that specific region and price range and outputs its prediction based on the data. As of right now, I have cut it down to include only regions that have prices less than 50 cents an avocado, and otherwise the graph would have just been way too large. And once it makes that prediction for a region, it moves on to the next branch or region and repeats the process.
Brent was actually the one who implemented this model, but unfortunately he couldn't come here today. So linear regression is a simple model that takes in data points and generates a line that best fits the data. It can take multiple factors into consideration when creating a line. Brent used linear regression to take both total volume and data into consideration when predicting the price. Brent also used linear regression to individually compare data to average price and total volumes to the average price. The three-dimensional graph below shows the predicted prices of avocados generally by Brent's model after taking in test data points. The two-dimensional graph below individually compare total volume and date to average prices. Random forest uses bagging to create an uncorrelated forest of decision trees and combining the results for a more accurate result. Here, a random forest regression model was implemented to predict prices of both organic and conventional avocados throughout the United States from 2021 to 2025. The model was trained with states and average prices of avocado sales from each region from January 2015 to November 2022.
Similar to Jefferson, in order to effectively analyze our avocado dataset, I also used the random forest regression model, which uses an ensemble bagging learning method. First invented in 2001, this machine learning model consists of a series of decision trees that are connected in a way so that the end prediction is less prone to overfitting. The aspect of the dataset that I was specifically focused on was the average price of the avocados. I came to the conclusion that the columns that had the greatest correlation to the average price was the date and the total volume. Using the total volume and date as X values and the average price as a Y value, I put this data through my random forest regression model and create a few visualizations to represent the data. Now, as you can see, the first model that I've created is a 3D scatter plot, which correlates the date and the total volume to the average price of the avocados. And then the color scale is a continuous color scale, which also shows the accuracy of each of the evaluations made by the model. The colors, all the points that you see that are closer to purple are the ones that are more accurate. They have an RMSE or root mean square error of almost 0, and the ones that are yellow are the ones that are the least accurate. Now, as you can see, almost all of the data points are close to 0. And this is also exemplified in the second model, which is basically a scatter plot which correlates the actual value of the data of the predictions to the predictions themselves. And almost all of the scatter points are close to the line X is equal to Y. So almost all of them are relatively accurate. And this third one is just a small subset of what the decision trees in random forest actually are, just one small aspect of it.
Logistic regression is a classification algorithm that predicts a binary output, basically yes or no, based on previous data. I created a logistic regression model that predicted whether the prices of avocados were greater or less than $1.25. The x-axis is the date spaced out in weeks, and 0 on the y-axis stands for the price being less than $1.25, and 1 stands for the price being greater than $1.25. I also created a polynomial regression model, which is basically where you fit a polynomial function to the data. Again, the x-axis is the date and the y-axis is the price.
From analyzing our models, we discovered that avocado prices usually rise from the start of spring to midsummer. We also discovered that the coastal areas, especially the west of the United States, usually had the highest prices of avocados. Our models also show that increasing the number of avocados sold decreases the price of avocados, displaying a correlation between price and volume sold. Lastly, as time goes on, prices slightly increase, probably due to inflation, and are likely to remain above $1.25. In the process, we used several different models mentioned prior, but there was one model that performed distinctly well compared to the others. Using the RMSE to calculate efficiently, we found that the LSTM neural network model had an RMSE of almost 0.11, which was 0.15 higher than the next closest model. In the future, we will utilize the information that we have to produce an interactive web page in which corporations can access and use our best performing LSTM model to better run their companies.
Okay, I want to shout out to all the members in my team. We have Sean, Amon, Provia, Brent, Eliana, and Jefferson. Thank you for your effort and collaboration. I was so impressed that you can complete such a wonderful portfolio in 3 weeks. Thank you all.
Awesome, awesome, awesome. Can we get a round of applause for our Valorous Vampires? Thank you guys so very, very much for presenting. So as mentioned, that was our last group. And before I lose your attention, I would like you guys to please, 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 please fill out our most wonderful form. We have basically a feedback form on how you guys felt about the summer camp overall. And as I'm talking, DSIs or data science interns, if you would please copy that over into your respective Discord channels, just so we can get that out to as many people as possible. We went through the process of completely rebuilding our curriculum from the ground up before this summer based off of feedback from last summer. So this is something that genuinely completely changes what we do. Your feedback, like unlike with other companies, it's not just us checking off a little, we did a good job kind of thing. It's genuinely constructive and genuinely changes what we do year in and year out. So please, if you are willing to, just spend some time, shouldn't take more than 5 minutes. Just go through, fill it out. And this is also for parents. So anyone and everyone, please, 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 pretty please with sugar on top, go ahead and fill out that form. I would highly appreciate it. But with that out of the way, for all of our wonderful students, you guys have been absolutely awesome. I think all of our parents and all of the other students can say without a shadow of a doubt that this has been just an incredible experience. And you guys have worked incredibly throughout all this time to get some cool stuff done. The power of this course, though, isn't just in what you learned. It's also in your continued ability to teach yourself moving forward and also your ability to engage with our Discord. The Discord is going to sit there forever and ever and ever and ever. And I'm sure you realize working with the people around you that this is a special group, like bigger and more willing to learn, more willing to engage, more willing to help you out and work hard to try and get things done. Think about the power of having a Discord server with hundreds of students from years and years of experience able to help you out with anything you'd like. For that reason, I would encourage you guys to not be a stranger. Head into the Discord if you have any questions, comments, concerns about anything at all machine learning related. Please shoot a message out there. Otherwise, if you don't want to put it out into the world, I love teaching. Like pretty much everyone here who teaches does it because they love it more than anything else. So if you have something cool you see online, like you see a quick YouTube video of some guy teaching an AI to play a game, or you see something cool about like a new generative adversarial neural network that came out and you just want to like get some more information about it, the Discord's the place to go. We try to facilitate an environment of learning and helping each other out. So please, like I said, don't be a stranger. Head in there if you have any questions or if you just want to tell people about your day. All that said, though, we would also like to announce, I would also want to see you guys like work on another project just on your own time, maybe something that you'd be more interested in or something that you can decide the end goal of. And also we'll be announcing our Camper Kudos winners in the chat and details about Team Tomorrow as soon as it is finalized. So be on the lookout for that in our Discord as well. Just another reason to pay attention to it. All that said, though, it has been a wonderful 3 weeks, my friends. And with that, we are done with our presentation for the day. You guys have been awesome and wonderful. So please, like I said, one last time, fill out that form and we will see you sometime soon, hopefully. Till then, friends, take care and have a good day. All right. I'll stick around for a bit for any questions, but you guys are free to go. Bye, everyone.
Just want to shout out for all the instructors, for Cameron, for Mitch, right? Really, without those guys, like we won't be able to have this great experience. So really appreciate and thank you for all the hard work. Thank you very much, Vishnu, for leading the session and all the DSIs. Thank you very much. Yeah.
Let's get a round of applause for all of our DSIs too, just on our way out. You guys absolutely killed it.
Yeah. Can't do it without you.
All right. So if there are no other questions or any other closing comments, I will go ahead and close out the Zoom and